your boots are on fire. I'll make you jump like you touch a live wire. Ain't no sitting down when I get in the zone. Just give me my crown, let the king take his throne. Oh, hi. You're gonna move it. You're gonna move it.
We had a good tour of the campus. Shall we go for lunch now? Oh, my phone doesn't work. What's going on?
Really? Oh, my Galaxy Watch also doesn't work. Can it be because of OLED? I was told that wireless charging system can induce some interference to electronic device. Would better ask our expert Changmin.
Let's go.
You can never go wrong with coffee after lunch.
Hey Changmin, when you call around OLED, my smartphone suddenly attacked. They didn't work well. Is it because of OLED?
That's right. A wireless charging system for large power application like OLED generate magnetic field noise. It can cause problems with other electronic device. This is called EMI.
The wireless power transfer method requires an inverter to transfer power which operates on square wave signal. The harmonic frequency of the square wave caused an EMI problem. The EMI caused interference to other electronic devices using frequency of odd harmony. These days, EMI problem has become a major problem. It must be solved.
Shall we go to check it?
Oh yeah, let's go! An inverter is used to provide the switching voltage to the coil.
The power is transferred to the RX coil through inductive coupling between TX and RX coil.
And power is transmitted to the rectifier and load stage. Now we can charge the battery or use the application right away.
The EMI is mainly generated in the TX and RX coils. Now I show you how to reduce EMI by several shielding methods. Passive shield can cancel the magnetic field generated by guiding the magnetic field to ferrite, or by using eddy current of aluminum plate. How do you think about it?
However, since you use ferrite or aluminum plate, the total system size increases.
It is also expensive and heavy.
Is there any other shielding method?
There is a reactive shielding method using a shielding coil. The magnetic field induced by the shielding coil can cancel the EMI through phase control of the current.
Oh, it just uses a coil and capacitor. This is so simple, right?
Yeah, I think this method is so cool.
Okay, then let's go to the professor to show this one. I'm sure he'll like it.
The reactive shield method is a good idea, but don't you think the efficiency is decreased and overcoupling occurs between the coils?
Alright, Professor. Is there any way to solve the efficiency reduction problem? When the coils are close, overcoupling occurs. How about applying this dynamic? Hey guys, I got a good idea.
Oh, Changmin, let's talk together.
I'm so curious. Come on, tell me about it.
Okay. First, do you remember when we did the relative shielding experiment last time? and the efficiency of the system decreased, right?
Of course, you said that the problem of additional loss is caused by current flow in the shielding coil.
Yeah, and if the distance between the transmitter and shielding coil is too close, there is an overcoupling problem, and that causes a frequency split situation.
You guys all remember it well. So I thought about the advanced relative shielding method.
First, I assume a situation where overcoupling occurs between TX and the shielding coil. In this case, the resonance frequency is split in terms of input impedance. The overcoupling situation happens when the shielding coil and TX coil are very close. I put a lot of thought about how to apply reactive shielding considering frequency splitting phenomenon.
The operating frequency should be selected as an even frequency, avoiding the split frequency which is large. And basically the harmonic frequencies is after the odd harmonics in the inductive region to suppress the leakage magnetic field.
So the proposed reactive shielding method is using the overcoupling. That way, the operating frequency is located in the capacitive region, so it is possible to increase the efficiency. Furthermore, the harmonic frequency of the third harmonic is located in the inductive region of the shielding coil. It reduces EMI.
Thus, passive and reactive shielding method can be used to reduce EMI caused by harmonic frequencies, even though the conventional reactive shielding method is an EMI reduction method. We reduce the efficiency. The proposed reactive shielding method is kill two birds with one stone by reducing EMI and increasing efficiency.
That's a good idea. This is a brilliant idea, Changmin.
Before the experiment, how do you make the overcoupling?
I think we assume the gap between the TX and RS coil is very small. Where should we place the shielding coil?
In my opinion, the shielding coil should be placed on the TX to increase shielding effect. The gap between TX and RX coil is selected based on the coupling coefficient that can achieve the maximum EMI reduction considering the atmosphere. According to the CISPR standard, loop antenna measures EMI noise at 3 meter distance from the coils.
The EMI is decreased by a shielding coil.
How much has it decreased?
If the target power is 50 watt, the power transfer efficiency increased by 5%, and the EMI component at odd harmonic frequency could be reduced by up to 7.5 dB.
This is amazing.
I think so. This result is really meaningful. What about checking with our professor? Professor, we will revise our methodology we had showed you last time, and we came up with a great idea.
Shall we take a look together? Haha, this is a great idea, and you guys did a great job together. I think it would be better to think about application using this idea for the future research.
The wireless power transfer, the EMI problem by inverter, the representative shielding method is passive shielding and reactive shielding method. In general, the reactive shielding method is widely used. However, its efficiency is also slightly reduced depending on the system. Therefore, we propose a method of reducing EMI noise and increasing efficiency.
The proposed reactive shielding method can be applied to various industrial applications. Most commonly, it can be used on mobile devices that are vulnerable to EMI noise. In the case of electric vehicles, there is an issue with weight and cost. Therefore, the reactive shielding method can be applied more effectively than the passive shielding method.
Thank you for watching video.
Bye. Oh, where should we
Can it be because of OLED? 다시 이거 너무